right. These notes are going to look at cosmology. Sounds fancy. It's basically the study of the universe. All right, and so we're going to first look at um, how the universe was created. This is the most accepted theory, and you guys have probably heard this, if anything else, from the television show The Big Bang. And this is, once again, the most accepted theory of how the universe was formed. The Big Bang states that the universe started with a Big Bang or an explosion, uh, and it has been expanding ever since. The Big Bang is not an explosion of matter into space, but it's rather the rapid expansion of space. And so, if you look at like say this whole is the universe. Well, what happened eventually is it is going to erupt, and then it's going to, as a result, it's going to expand very quickly. All right, so it's going to expand outward. And I'll be honest with you, this stuff goes well beyond my understanding. And I don't even really feel bad saying that because I don't think a lot of people understand this. Because like if you think of this as the universe, once again, it's not that this is all the matter in the universe, that space exists and explodes and everything gets thrusted into space. Like this is our universe. Like what's out here? I don't know. Like this stuff is crazy to think about. Like what's the universe expanding into if this is the universe? I'm getting deep. Like what's that? Like, hey, I'm just hanging out here outside the universe. Like I don't know what that is. I don't have any idea. Like it just blows my mind to think that that's what it is. It's saying that the universe was once so compressed, and then it started with an explosion. Once again, space itself is expanding, and it's going to rapidly expand. That's obviously not drawn to scale or time because it's going to happen really fast. And so, and once again, in a way, really knows this is all based on mathematical formulas and what equations that can best explain what we observe today. We can see echoes of what happened, and scientists try to piece it together. But this is the best possible explanation that we have. And once again, my mind is blown thinking about that because I'm like, so the universe expanded into like, because when you think like emptiness, it's like, well, that's space. Well, it's like, no, this is space. This is our universe right here. This is space. So what's it expanding into? Another form of space? I don't know. Like I said, I don't really feel that bad not understanding this. There's probably a lot of people smarter than me. I probably should erase that. It kind of looks like a piece of pizza. There's probably a lot of people smarter than me that don't fully understand this. So, but that's what the theory states. And so it's a pretty crazy thing to kind of wrap your mind around if you really think about it. But that's the theory as to what happened. And once again, I don't feel that bad about it because we'll talk about there's a lot of forces and energies that are causing our galaxies and our universe to move that we don't even understand. We just call it dark energy. Scientists don't understand it. We can't even observe it. And so I don't feel that bad about it. And some of the evidence of this is that we talked about this already, is with that red shift, blue shift. Everything in the universe, if objects are moving away from us, and this is once again the Doppler effect. We talked about this with the Doppler effect. Objects that move away from us have a red shift. And if you don't remember why, once again, if all objects are emitting a light, I drew this earlier, but if all objects are emitting a light, and let's say we get two wavelengths here before it reaches, I don't know if I could draw an eye. Stand corrected. That is fantastic. Hey, this is a lot harder on the screen. But basically what happens is as that object emits that light wave, as it moves further away, what happens is that wavelength, we got two wavelengths. So I'm going to try to draw two wavelengths. And so it gets stretched. That wavelength gets stretched and red, once again, on the visible light spectrum. The reason why it appears red is because red has the longest wavelength. And then if it were to appear blue, if it would have a shorter wavelength, if it would be moving toward us two wavelengths, the shortest wavelength is blue. Blue has the shortest wavelength, red has the longest. So since that, once again, it's emitting light, and as it emits that light from here, as it moves really fast away, that wavelength, by the time it reaches our eyes, gets stretched, causing it to be red. And if it moved really fast toward us, that wavelength would be compressed because it's emitting light as it started from here to here. And so it still is two wavelengths, but it gets compressed, causing it to appear blue shifted. And so that's what we talked about with redshift, blue shift. In redshift, all objects, once again, we can't see this with the Doppler effect. Our eyes aren't sensitive enough, but our instruments can pick this up where everything in the distant galaxies, all the light from the distant galaxies are more slightly redshifted than, we don't see any blue shift, meaning nothing's moving toward us, everything's moving away from us. And so it gets that idea that everything was once centrally located, and then it's rapidly expanding, and it's been expanding ever since. It's moving away, everything's moving away. And so that's some of the evidence. And then Hubble came up with this law. He said the shift is creating expansion, stretching its space itself. Light waves traveling through space lengthen as it expands. Red shifts. Uh, that's not what I thought. I had more than that. Sorry. But anyway, essentially, and what Hubble's law talks about is that not only are red shifts seen from all galaxies outside of the Milky Way, but it's also, he talked about that they're even greater redshift. The further out you go, they're even moving faster the further out you go. And so galaxies that are close to us are not moving as fast away from us as galaxies that are, let's say double the distance away. And so galaxies that are even further away are going to be expanding even more, and they're going to be not expanding even more, moving even faster away. So not only is our universe expanding, but you also have to know that our universe is accelerating. It's getting faster away. And if there's anything we learned about with acceleration, it's like, well, if something's accelerating, it needs some kind of force. It needs some kind of energy to be added to it in order to have that acceleration to occur, because things just don't accelerate. When the initial explosion, there's nothing getting in its way. So if it was moving at a constant speed, you'd be like, yeah, I get that. That makes sense, because Newton's law talks about that. When an object's in motion, it'll stay in motion unless an unbalanced force acts on it. Well, there's no unbalanced forces in space that are going to cause it. So if it was moving at a constant speed, we would get it, but it's not. It's accelerating, and that confuses scientists. And so there's a couple things that they talk about to explain that, and they don't really know what it is. There's really only a very small portion of matter in our universe that we can detect even. We don't even know, and this is why I said I don't feel bad about not understanding some of this stuff, because I'm like, I feel like we don't even really understand it. It's such a massive concept to try to understand our universe and just how big it is and the forces that guide it. Regular matter, some say, I don't know what the number is, it's like 5%. Some people say we only can detect 5% of the actual matter and energy that exists in the universe. It's very the planets, the stars, things that we can observe, but there has to be something else going on out there. And so it says regular matter is only visible or detect mass. However, if only regular matter existed, we wouldn't be able to explain why the Milky Way and other galaxies rotate. We wouldn't be able to explain why, how other galaxies interact with each other. There's little that is understand. It's unseen. There's little understood about matter that affects the galaxies. And so we can't explain, based on what we can observe, only what we can observe, why galaxies behave the way they do, why galaxies interact the way they do. And so what scientists use to explain that is they say it's dark matter. There has to be some kind of matter that is causing this. We just don't know. We can't see it. We can't detect it. I feel like I talk about like a Thor movie when I talk about this, or like a adventure, like the dark matter. That's how Thor sounds, by the way, in case you haven't seen the movies. And dark energy. And dark energy also. Dark energy is data suggests that the universe is expanding at an accelerated rate. Explaining this acceleration is difficult. Once again, we talked about the objects that are accelerating. They have to have something causing acceleration. We don't know what that is, and so there has to be some kind of dark energy that is present, causing this acceleration. That's one hypothesis is that something has to be causing it. We don't know what it is. We can't detect it, but there's something causing the acceleration of our universe because it's not growing at a constant rate. If it was growing at a constant rate, that would make total sense. We'd be able to be like, well, yeah, once the Big Bang happened, it's going at a constant rate, but it's accelerating. And things just don't accelerate without having something acting on them. And that's what Hubble's law talks about. That's where it's at. Hubble's law talks about the further a galaxy is away from us, the faster it's going to be moving away from us. And you're going to have to know that as well. All right, so there's a lot about this that we don't fully understand. We know based on evidence we can see echoes of the past, and we scientists can theorize about the Big Bang and that everything was clustered and that everything's now moving away, but we don't understand why. We don't understand some of the forces that are acting on, or some of the matter that's acting on the different objects. I mean, there's a lot that is still up to question. The universe is a pretty dang big place, and so we don't quite get it. But there is they use terms of dark energy and dark matter to kind of explain those things. And so a couple things that we're going to definitely talk about that you're going to have to definitely know. We're going to have to know about Hubble's law. You're going to have to know about dark energy, kind of what's happening there. I'll kind of highlight some of these terms that you'll need to know. Sorry, I'm going back. Should have done this initially. You're going to have to know that the evidence for the universe expanding, which is redshifted, and we've talked about that some. And then you're going to have to know a little bit about dark matter and how it affects galaxies. Hubble's law, Hubble's redshift, and those are some of the key points that you're gonna have to know about the universe. That's all I got for you.